everybody. Today we are here in Milstein Library on Barnard campus. I'm Harper.
And I'm Caroline.
And we're here to ask some people some trivia about Columbia University and maybe a surprise at the end.
We're going to test their knowledge on Calc 2.
Yay! All right, I'm Harper, and today we have some trivia with
Jelly's best.
Seema.
Sheen.
All right, your first question is, how many people were in the first graduating class of Columbia University?
120.
7,000. In the first one ever?
Yes.
20.
5.
Oh, really?
I know, very small, yeah. Very close. The correct answer was 5.
Got it. Rigorous institution.
Yes. Good guess, 5. I know. Can you define an alternating series?
An alternating series, like sports terminology?
Like a math alternating series.
Math, like actual
math.
alternating series. I don't know, like calc.
Good answer.
An alternating series is a series that alternates between positive and negative signs. Now, to give you like a sample of what this will look like, the general form of an alternating series is this. So, the exponent here, which is n, as it increases, the trend that you'll notice is that the sequence will switch from a positive to negative sign, or the series will switch from a positive to negative sign. And there's a lot of flexibility actually with like how this particular part here is represented, and as well as the index. So the index could be 0, or it could be 1, or any other number, and this could be n plus 1, n plus 2, etc. You get the point. But essentially, as this number increases, the signs of each term in the series will switch between a positive and a negative value. And now I'm going to give you a couple of options, and you're going to tell me which is an alternating series based off of what I just taught you. Does anyone in the class want to tell me what it is? Yes.
Is it option A?
Option A is alternating. What about option B?
Yeah, I think it's also.
Oh my gosh, you're so smart. Wow. And what about this?
No.
Also correct. Okay. What did you use to tell you?
Well, I saw that the number in the parentheses in the first two was negative.
Mm-hmm.
And then it has an exponent, so when it's to an even number, it'll be positive, and when it's to an odd number, it'll be negative.
Yes. Okay. Now I have another question for you.
Oh boy.
Which of these converges?
Oh, I don't know.
Oh my gosh, that's perfect because So, now I'm just going to briefly explain what each series is. Okay, so for option A, we just have a regular alternating series where the two critical parts would be, I'm just going to rewrite it one more time. We have a negative integer, which could be 1 or it could be any other value, to be honest, raised to an nth power, which could be added to an integer, which I'm going to represent as k, because k could be positive or negative, so it doesn't necessarily have to be just to the n. It could be n plus 1, or n minus 1, or n minus 2, or 40. And then it's multiplied by the sequence, which I'm going to represent as b sub n. So here we just have a regular alternating series. And for option B, what we have here is a geometric series where A is 2. You guys are going to learn about this in another lesson. That's not my responsibility. Where A is 2 and R is negative 2/3. And it's raised to the power of n. And because the negative is inside of the parentheses, as n increases, n is odd or even, you're going to get either a positive value or a negative value in this series. And then the final one is our harmonic series, which we know diverges, and it's just a special series, guys. Sorry, I don't have any other things to add to that. Okay, so a critical way that we can tell whether a series converges is by using different tests. So for a geometric series, we know that if the absolute value of r is less than 1, that it converges. So in this case, we can be certain that B converges. Here, C is a harmonic series. Because it's a special series, we know that it does not converge. But how do you know whether or not A converges? Well, that's with the alternating series test. Okay, now I'm going to explain what that is. Okay, and as you can see here, the partial sums of the alternating harmonic series all oscillate around a fixed number, and this fixed number is the sum of the series. Okay, now I will get into the actual alternating series test. Okay, so the first condition that must be true is that b sub n plus 1, which is the next term in the series, is larger than b sub n. And then also that as we find the limit of b sub n as n approaches infinity, it must equal 0. The limit is 0. And that's how you prove that an alternating series converges.
Hi guys, it's Caroline, and we're going to talk about estimating the sum of alternating series. So in order to estimate the sum of an alternating series, we're going to use the partial sum of any convergent series. And we're going to say that the error with using this is r sub n, the remainder, which is the difference between the total sum of the series and the partial sum of the convergent series. Moving on to alternating series estimation theorem, if the sum of an alternating series satisfies both conditions that each term is gradually decreasing and the limit of the term is equal to 0, then we're going to say that the absolute value of the remainder is less than or equal to the next term. Overall, from this theorem, we have the proof saying that S lies between the partial sums of S sub n and S sub n plus 1, so it's S lies between the difference between the next two terms. And because of this, we can say that the remainder is less than or equal to the difference between these two terms, the absolute value of the difference between these two terms, which is equal to the next term. Hi everyone, now talking about absolute and conditional convergence. So we're going to say, given a series, its corresponding series is the absolute value of it. And a series is absolutely convergent if the absolute value of its series converges. We can see that here with the example that both the series, whether or not it's in absolute value brackets or not, has the same exact values that follow. So basically it's the sum of the same exact values. However, in a conditionally convergent series, a series is conditionally convergent when the regular series converges, but the absolute value of the series diverges. And we can see that with this example, where the regular series alternates from negative to positive, but the absolute value of the series stays positive consistently. So the sums of the two series are not equal, thus making the original series conditionally convergent.
What year were women accepted into Columbia for the first time?
I swear did they accept? What year?
Yeah.
75.
Oh, this is so awkward. After Barnard College was established.
Very good.
1950.
I should know this, I went to too many tours. Next question.
Okay, next question. 1983 was the correct answer.
1975. Close. 1983. Yeah. Do you know anything about the ratio test? Do you know what the ratio test is?
No, I haven't done math since I was 16. So, should I know what the ratio test is? Okay.
We'll teach you.
Okay, so when we calculate ratios of consecutive terms, we can tell how fast terms of a series are increasing or decreasing. So the ratio test tells us if the ratios approach a number less than 1 as the term goes on, and then the series converges. So essentially it helps us determine if a series is absolutely convergent. So it's convergent if the limit as n approaches infinity if the limit is less than 1, then it's convergent. If the limit is greater than 1, then it's divergent, or if it equals infinity, it's divergent, and then if it equals 1, it's inconclusive. Okay, so for the ratio test, this is our example. So we have a series 3 to the nth power over n factorial. So first, we should identify what a sub n is, which is 3 to the nth power. Essentially the same thing, and then a sub n plus 1, we just plug in n plus 1 for the n's. So it's exactly the same, you just plug it in. So then first, we should write the definition. So the limit as n approaches infinity, the absolute value of a sub n plus 1 over a sub n. And then we can rewrite this to be limit as n approaches infinity, absolute value of a n plus 1 over 1 times 1 over a n absolute value. So then we focus on this it's the same definition, just written differently to help us with this series. So we write it as limit n approaches infinity as 3 to the n plus 1 over n plus 1 times, this is the reciprocal of a sub n, so it's n factorial over 3 to the nth power. Then we're gonna go here, and then, so then we have limit as n, we're just gonna rewrite it so it's easier to see what we can cancel out. So we have 3 to the n times 3 to the 1 over n plus 1 times 1 n. So you just write it out. Then we can see here like what we can cancel out. So we can cancel this out, cancel this out. So what we're left with is limit as n approaches infinity, 3 over n plus 1. Then we can plug in the infinity. So 3 infinity plus 1, which is just going to go to 0. 0 is less than 1, so the series converges.
All right, my next question was, what was the original name of Columbia University?
The original name? Columbia?
Yes. What was the original name of Columbia University?
I have no idea.
King's College. Wow, there she goes. Can you define the roots test?
No.
Okay, hi. This is the 11.6 root test, and use the root test to see if the series converges, diverges, or is inconclusive. Okay, so there's 3 rules that you can follow when you use the root test. So the first one is, if your limit as n approaches infinity, the nth root of a sub n is less than 1, then the series is absolutely convergent, which means that the series converges. If your limit as n approaches infinity, the nth root of the absolute value of a sub n is greater than 1 or equals infinity, then your series diverges, or your series is divergent. And if your limit as n approaches infinity, the nth root of the absolute value of a sub n is equal to 1, then your root test is inconclusive. Okay, so here's an example of using the root test to find if your limit converges, diverges, or is inconclusive. So as a reminder, if your limit is less than 1, then your series converges. If your limit is greater than 1 or equal to infinity, it diverges. And if your limit is equal to 1, then it's inconclusive. So here's an example of our series. So we have 1 over n cubed plus 1 over n to the nth power. And if we put that into the limit formula, then we get the limit formula is limit as n approaches infinity, you have the nth root of the absolute value of a sub n. So in this series, your a sub n is going to be 1 over n cubed plus 1 over n to the nth power. So if you put that into the limit equation or limit formula, you're going to get limit as n approaches infinity, the nth root of 1 over n cubed plus 1 over n to the nth power. And if you simplify that out, right, so then you get the nth root of something is just anything to the 1 over n, right? So you're going to get limit as n approaches infinity of, right, 2 brackets, 1 over n cubed plus 1 over n to the nth power, and then you raise that all to 1 over n to eliminate your nth root. When you have an exponent of an exponent, you multiply the 2 exponents together. So when you do that, you get n over 1. That's the exponent from 1 over n cubed plus 1 over n multiplied by 1 over n, which you're getting your 1 over n from the nth root part, and those cancel out. So then you're just left with 1. So all of this raised to 1 is just the value itself, right? So then, let's go. So then you have limit as n approaches infinity is 1 over n cubed plus 1 over n. Okay. At this point, you can evaluate each of these independently. So 1 over n, so the limit as n approaches infinity of 1 over n cubed, that itself is 0. The limit as n approaches infinity of 1 over n, that also approaches 0. So what you have is 0 plus 0, which is equal to 0, right? So your limit, so the final answer is limit as n approaches infinity of 1 over n cubed plus 1 over n is equal to 0. 0 is obviously less than 1, which means that your series ultimately converges. And that is how you can use the root test. That's how you can use the root test to see if your series converges, diverges, or is inconclusive. And in this case, because your limit approaches or is equal to 0, which is less than 1, it's going to converge.
What was the first ever sporting event played at Columbia University?
Like a sport, like any sport.
It's a sport. It's a common sport.
Football.
Football. Rowing.
Good guess. Baseball. Thank you very much for speaking with us today. Perfect. Okay, thank you very much for joining us today.
Welcome.